Let me tell you something that should keep you up tonight. Right now, as you listen to this, a chunk of ice older than our sun is sailing away from us. It came from another star, a dead star, most likely. A star that burned out before the Earth was even a thought in the cosmic mind. An ancient stellar furnace that forged planets, moons, and comets around itself when the Milky Way was young, when the galaxy was still assembling itself from clouds of hydrogen and helium, when the heavy elements we take for granted, carbon, oxygen, iron, silicon, were still being manufactured by the first generations of massive stars. And when we pointed the most powerful telescope ever built at this thing, the James Webb Space Telescope, a $10 billion instrument sitting at the second Lagrange point, 1,000,000 miles from Earth, folded like origami and launched on a prayer and a rocket, we found something inside it that made planetary scientists sit up in their chairs. Something that made astrophysicists stare at the data reduction screens and say out loud, "That can't be right." Deuterium. Not just a little, not just a trace amount within the margin of measurement uncertainty, an amount 10 times higher than anything ever measured in any comet, ever, in the entire history of cometary science. An isotopic ratio so extreme that it sits 12 standard deviations above the mean value measured in every protostar in the galaxy. 12 sigma. Let me put that in context for you. In experimental physics, we celebrate at 5 sigma. That's the threshold for declaring a discovery. 5 sigma means there's a 1 in 3.5 million chance that the result is a statistical fluke. When they found the Higgs boson at CERN, that was 5 sigma, and they popped champagne and gave out a Nobel Prize. 12 sigma means the probability of this being a coincidence is so small that the number of zeros after the decimal point would fill this entire script. It means the deuterium enrichment in 3I-ATLS is not a fluctuation, it's not measurement error, it's not a calibration artifact. It is a signal from an environment that no longer exists anywhere in our observable neighborhood. So what is deuterium? It's heavy hydrogen. Regular hydrogen, the most abundant element in the universe, has 1 proton in its nucleus and nothing else. Deuterium is hydrogen with a bonus, 1 proton plus 1 neutron. It's heavier. It behaves differently in chemical reactions, especially at low temperatures, because that extra mass changes the zero-point energy of any bond it forms. And here's the thing that connects deuterium to the title of this story. The thing that connects a frozen comet from the dawn of the galaxy to the most ambitious energy project in human history. Deuterium is the primary fuel for nuclear fusion. When you fuse deuterium with tritium, another hydrogen isotope, this one with 2 neutrons, you get helium-4, a free neutron and 17.6 million electron volts of energy. That's the reaction powering tokamak designs at ITER in southern France. That's the reaction powering the National Ignition Facility's laser experiments. That's the reaction that, if we can ever bottle it, would give humanity effectively unlimited clean energy for millions of years. It's also the reaction that powers the sun. Every second, deep in the solar core where the temperature hits 15 million degrees and the pressure is 250 billion atmospheres, hydrogen nuclei are being squeezed together so hard that the strong nuclear force overcomes their electromagnetic repulsion. Protons fuse with protons, creating deuterium as an intermediate step, and deuterium fuses with more protons, building up to helium. That chain reaction, the proton-proton chain, releases the energy that illuminates our entire solar system. The energy that makes life on Earth possible. The energy you're consuming right now,
because the photons that grew the food that became your breakfast started as gamma rays in the sun's core about 170,000 years ago. Deuterium is the key to stars. It's the key to fusion. It's the key to the universe's energy economy. And this rock from another star system, this ancient, frozen, battered traveler that has been drifting through the void for longer than the sun has existed, just sailed through our solar neighborhood, carrying a concentration of that isotope unlike anything in our cosmic backyard. A concentration that reflects conditions in the early Milky Way, conditions that no longer exist, conditions the modern universe has essentially erased. That's what I mean by fuel the universe forbids. Not that deuterium can't exist, obviously it does. The universe made plenty of it during Big Bang nucleosynthesis in the first 3 minutes after the cosmos began. But over time, stars consume deuterium. They burn through it almost immediately when they ignite. Every generation of stars that lives and dies reduces the total deuterium budget in the interstellar medium. What's left gets recycled, mixed, heated, enriched with heavier elements. The ultra-cold, pristine, metal-poor conditions that could concentrate deuterium to the levels found in 3I Atlas, those conditions belong to the Milky Way's childhood. They're gone. 3I Atlas is carrying a chemical fingerprint that the modern universe has erased everywhere we can see. Now, let's be absolutely clear about what this means and what it doesn't. This does not mean aliens sent us a fuel pod. It does not mean 3I Atlas is a spacecraft. It does not mean some ancient civilization stockpiled fusion reactant in a comet and launched it across the galaxy. The Breakthrough Listen initiative, the most comprehensive SETI program ever conducted, already pointed the Green Bank telescope at 3I Atlas. That's the largest steerable radio dish on the planet, 100 meters of collecting area parked in a radio quiet zone in the mountains of West Virginia. They scanned every frequency from 1 to 12 gigahertz using 4 different receivers with sensitivity down to 1/10 of a watt. That's less power than the LED on your phone charger. They found nothing artificial. No signals, no technology, no modulation. Just the quiet electromagnetic signature of a natural object doing what comets do. The Meerkat array in South Africa scanned it separately across 900 to 1600 megahertz. Nothing. The Allen Telescope array observed it. Nothing. The Muryang radio telescope at Parkes in Australia hit it 3 separate times, July, September, October, with an ultra-wideband receiver sensitive from 700 to 4000 megahertz. Nothing. 3I Atlas is not a spacecraft. It's a comet. But it is the strangest comet we have ever seen.
And the deuterium is just the tip of the iceberg, or perhaps more accurately, the tip of the ice mountain. Because to understand why 3I-BTALS is a once-in-a-civilization event, you have to understand everything else that's wrong with it, everything else that's weird, everything else that made astronomers around the world cancel their vacation plans and spend the second half of 2025 staring through every telescope they could commandeer. So let's start at the beginning. July 1st, 2025. It's nighttime in Chile's Rio Hurtado Valley. The sky is black and infinite. The Atacama desert air so dry that moisture is measured in fractions of a millimeter. A 20-inch telescope, not large by modern standards, smaller than some amateur instruments, is doing its nightly scan. This is one of 5 instruments in the ATLAS system, the Asteroid Terrestrial Impact Last Alert System. Its job is planetary defense, watching the sky, looking for rocks that might be on a collision course with Earth, cataloging near-Earth objects, measuring their brightness, their movement, their orbits.
On that particular night, the system flags something. A faint point of light, magnitude 17.8, far too dim for the naked eye, barely a whisper in the detector noise. The preliminary designation is forgettable, A11PL3Z, but the software notes something unusual about the way it's moving. The rate of angular motion across the sky, combined with its brightness, suggests an object that's either very close and small or very far and fast. Within 6 hours of the Atlas detection, astronomers at the Zwicky Transient Facility, a wide-field survey instrument at Palomar Observatory in San Diego County, California, pull their archival data and find the same object in images from June 28th and 29th. More detections are found going back to June 14th, and even earlier, all the way back to May 21st in data from the Weissman Astrophysical Observatory in Israel and further Atlas archives. The object had been passing through our solar system for weeks, hiding in plain sight, or rather, hiding in the dense star fields of the galactic center. 3I BTALS had been cruising in front of the Milky Way's most crowded stellar real estate, in the direction of the constellation Sagittarius, where the sheer density of background stars makes picking out a faint, moving smudge extraordinarily difficult. But now, with enough data points, enough positions at enough different times, the orbit fitters get to work. And what they find makes jaws drop across every astronomical mailing list on the planet. The orbital eccentricity is 6.141. To appreciate what that number means, you need to understand a little orbital mechanics. Every object in the solar system traces a path described by a conic section, a mathematical shape you get when you slice a cone at various angles. A circle has an eccentricity of 0. An ellipse, the shape most planets follow, has an eccentricity between 0 and 1. Earth's orbit is nearly circular at 0.017. Pluto's is more stretched out at 0.25. An eccentricity of exactly 1 is a parabola, the mathematical boundary between a closed orbit and an open one. Oumuamua, the first interstellar object, had an eccentricity of 1.2. Just barely hyperbolic. 2I Borisov was 3.4, clearly unbound, clearly interstellar, but still with a noticeable curve to its path as it swung around the Sun. 3I BTALS has an eccentricity of 6.14.
There's one more piece of the pre-perihelion puzzle that ties these observations together: the extended water source. NASA's Swift Observatory, a satellite designed primarily for studying gamma-ray bursts but equipped with a versatile ultraviolet and optical telescope, observed 3I ATLS on July 30th and August 1st, 2025. The comet was still about 3.7 astronomical units from the Sun. Swift detected the ultraviolet signature of hydroxyl radicals, OH, in the coma. Hydroxyl is a fragment of water. When water molecules are broken apart by solar ultraviolet photons, one of the products is OH, which then fluoresces in the UV. But the spatial distribution of the OH emission was odd. Modeling by Zexi Xing and colleagues at Auburn University suggested that the water wasn't sublimating directly from the nucleus surface. Instead, it was being released from icy grains in the coma, particles of water ice that had been ejected from the nucleus by the much more volatile CO2 outflow and were then slowly evaporating in sunlight at distances of 4,000 to 10,000 kilometers from the nucleus. This is what planetary scientists call an extended source. The water production is distributed throughout the inner coma rather than concentrated at the nucleus. It means the nucleus isn't really outgassing water on its own, at least not at those heliocentric distances.
The water ice is being physically ripped from the surface by carbon dioxide jets, lofted into space as solid grains, and then gently sublimating as the individual grains warm in sunlight. This has implications for the comet's internal structure. It suggests that the near-surface layers are dominated by CO2 ice, with water ice interspersed as a secondary component, perhaps filling pores or existing as inclusions within a CO2 matrix. The water is there, but it's a passenger, not a driver. Carbon dioxide does the heavy lifting. Carbon dioxide cracks the crust. Carbon dioxide launches the jets. Carbon dioxide powers the cryovolcanic eruptions. Water comes along for the ride. Think of it like a volcano on Earth. The magma, the molten rock, is the primary driver, but volcanic eruptions also carry water vapor, sulfur dioxide, carbon dioxide, and ash. The magma is the engine. Everything else is cargo. On 3I HELS, carbon dioxide is the magma. Water ice is the ash, and the eruptions are cryovolcanic, powered by the sublimation of CO2 ices that have been sealed beneath an irradiated crust for longer than our sun has existed. Post-perihelion, the picture changed dramatically. The JWST December observations showed that water production had increased 20-fold compared to the pre-perihelion SphereX measurements. The extended source mechanism was still operating. Icy grains were still being lofted and sublimating in the coma. But now water was also sublimating directly from the nucleus as the perihelion heat wave had penetrated deeper into the interior. The comet was finally warm enough for the first time in 10 billion years for water ice sublimation to contribute meaningfully to the outgassing budget.